All right, my name is Andrew Rubalcaba. I'm doing a talk on, here's the title of my talk, From Zero to Hero, DynamoDB Essentials and Integrations for Java Developers. Sorry, I was freaking out because we're all in a hurry. But yeah, let's just get started and get going into it. Just real quick, kind of like the background of my talk. How many, I'm sure I know my buddy Gangsta has kids, but mostly people who have kids, I don't know if you do, but I have a 6-year-old and a 9-month-old. Now with the 6-year-old, he's real picky about his food, right? If I try to get him to try something new, he's like, he doesn't want to try it. And sometimes I feel that we as developers are kind of the same way, right? Like when you want to, if you're used to something, especially when it comes to the motivation for my talk was because most of the times we're all used to relational databases and we like relational databases. And coming into something new is kind of like, you're a bit skeptical, right? You're like, I don't know if I want to try that. I don't know if I can do that. Yeah, exactly, right? It's just like a kid, right? Just real quick, a little bit about myself. I'm a lead developer for a company called 806 Technologies. We're down the street off of Tennyson. I do full stack development there. I do Java and Vue.js. I don't know if anybody here, like everybody I talked to at this conference, like 99% of everybody does React, right? Like I haven't met anybody that does anything else. I think Josh, I was talking to last night, does a little bit of Angular. No JavaScript ever. Okay, that's awesome. I'm also AWS developer certified and associate solutions certified. Although I think those are fixing to expire, so it's going to motivate me to keep them on there, right? Like to go renew them because someone's going to ask me about it at some point. Just real quick on the history of DynamoDB, right? Kind of the motivation behind it was in 2004, Amazon had a meltdown on their website, right? I think it was on a Black Friday or Cyber Monday, one of those days. Everything just crashed, right? And when they were doing their analysis of it, they were trying to figure out what exactly caused it. What they were realizing is their database just couldn't keep up on that type of massive scale, right? And I think I'm trying to remember the number of joins, but they had so many joins in their shopping cart queries, and the majority of them, they were just taking certain pieces out of it, right? So this query was just super big and it couldn't keep up. And I don't know if some of you have had that type of background, but I've had 2 bosses in my past who were data warehouse guys, and their natural inclination to everything, right, is like, let's just break this down into like 100 tables and organize everything really, really nice. And then when it comes time to go grab some of that data, right, you end up with like 30 joins to grab what, five pieces of data. Quick history note though, does anybody know why that is the way to do things? Like why break up all the data like that? No normalization, but what was the reasoning? What was the motivation behind it? It's not to duplicate, it was to save money, right? Because back like in the 60s and 70s when storage was just coming out, it was like super expensive to duplicate all that data everywhere, right? So you only wanted it in one place and one place only to keep your costs down. Now, over the years, what's happened, right? Storage has gotten like super, super cheap, right? I think I have a USB drive that's like 128 gigs, right? I mean, that was like crazy back then, right? That probably would have cost me millions of dollars in the 70s. Anyways, so out of that motivation, Amazon started looking around and they did this paper, right? They wrote this Dynamo paper, and out of it, it came out with these like guidelines, right, of what this database would look like for their specific need. And it was a white paper. I definitely encourage you guys to go check it out. I mean, it's very high level, but it's very interesting. But a lot of people read that paper, and as a result, we had other databases that came out around that time. I don't know if you guys have done Cassandra. Cassandra was one of the databases that came out as a result of that. I think that's still around. Ryek was another one. Voldemort. I think Azure Cosmos DB draws from that paper. In Gangsta, you've done some Cosmos stuff in the past. So a lot of it got that conversation going, right? And that was in 2007. Fast forward to 2012, and Amazon releases what is DynamoDB. So exactly what is DynamoDB? The short and sweet version. It's a fully managed NoSQL database service provided by AWS, right? And it's like, okay, what exactly does that mean? What does that buy me, right? So you get scalability and performance, and this is really what it was made for, right? It was the ability to keep up. I think trying to remember their P ratings, but they want to keep a consistent amount of performance no matter the load, and it's insane. They haven't done it this year yet, but I'm sure they will here in a couple of weeks. But every year, and I encourage all of you to go check it out. Every year, Amazon releases the numbers to what their performance was like, right, on Black Friday and Cyber Monday, right? They tell you what it was able to keep up with, and every single service, tier one, a tier one service in Amazon has to run on DynamoDB. I mean, that's how much they believe in it, right? The amount of scale that it's able to handle. I read one the other day, a guy was doing like, I think over like 5 million writes per second to DynamoDB, and it just consistent, right? It never, like, you never saw crazy spikes and anything. It's just, it does it. And then the best part of it, right, is you don't manage it, right? As a developer, are we responsible for managing? Do we want to manage any of this stuff? Not really, right? I kind of want offload that to somebody else and have somebody else worry about that. So it's got, again, high availability, fault tolerance, all that stuff that you expect, tunable consistency, integrated security. The integrated security thing is pretty cool because you can be as fine level as you want using AWS's IAM, and it gives you just a lot more control. And then also, you get some benefits of cost efficiency based on how you want to provision your tables and so forth. The global scalability in global tables is a pretty interesting feature that came out a while back. I was talking to a buddy of mine the other day, and he had clients in his client was in North Dakota, and they had this product that they were coming out with, and it was doing so well. And then they started getting customers, like I think like in Israel, and the Israel customers were like, "Hey, like this thing's running real slow, right? The like latency, right? Well, because all their stuff is in what region? It's in region 2 or US West 2, which is I think like in Oregon, right? And you're in Israel. Well, you have to make that trip all the way across, grab all that data, go back all the way across, right? Well, with the global tables, you could set up like this DynamoDB to be a global table and have it close to a region where your clients are at. And guess what? You end up reducing latency. So it comes with that. And the best part is you don't have to change your code at all. Your code stays the exact same, right? That's all handled for you. Some use cases for it, right? It's use cases for DynamoDB is it's great for web apps, mobile apps, IoT applications. I think I don't know. Trying to remember the guy's name. Is it Alex Debris, the guy who wrote the DynamoDB book? I think that's kind of how he got started. Somewhere in the IoT applications, gaming, and of course, Amazon uses it for e-commerce, and it lends itself very, very well to serverless applications. Who here is doing any type of serverless applications? Anybody here? Yeah, right. So if you do any type of serverless, right, the relational database is not going to be your preferred approach, and the reason being, right, because of the resources in the collection. I mean, the connection pooling, right? If you have these serverless applications like on AWS Lambda, right? You can scale from 0 to whatever, right? So suddenly you have 500 connections that are all going to your database without the connection pooling and all those other things in it. It's going to start to bog down the resource, and relational database just wasn't made with that in mind. And that's where I think services like DynamoDB just really, really shine when it comes to serverless applications. So Let's think about it here a little bit for when it comes to relational databases, because that's what we're familiar with versus a Dynamo database, right? What are some of the differences? Well, for one is the data modeling aspect, right? Um, the way you model your data is going to be very, very different. Whereas in your traditional relational database, you want to break everything out into the denormalized, or put it onto the different tables and so forth. Schemas in a traditional database, you have a fixed schema, right? I have a customer table, and I know that a customer table has first name, last name, email, phone number, and so forth, right? It's all fixed, and you have to know that up front. With Dynamo, it's schemaless, right? And you can add those things as you're going along. Now I want to track this other extra attribute. Well, you don't have to go out and modify the database table, right? Like normally in the traditional database, right? At my shop, we use Flyway, right? If we want to modify the table, add an extra column, I have to do a Flyway script. I have to do all these things and then apply that to the database. With DynamoDB, it's schemaless. Now it's schemaless, and it's not to say like, oh, I can dump whatever you want, but you have to be smart about how you organize that data. You still have to worry about that. Scalability. Traditional databases, the most people would back in the day when I was getting started, Oracle was a big thing, and if you wanted to scale your Oracle database, you just give it more CPU. It's more of vertical scaling, right? You can do some form of horizontal scaling, but it becomes a bit tricky when you're having to manage all the different pieces that go with it, such as your clustering and how you shard the data, how you break it up. Could become more of a nightmare. DynamoDB is not made for vertical scaling, right? It's more of I have all these machines. How am I going to effectively horizontally scale? So those are some big differences. Query languages, right? Traditional databases, we have SQL, and it's great for most of that. You're not going to get a lot of that SQL-like behavior over on Dynamo just because it's different, right? Joins and relationships, right? In traditional databases, again, you can join to all these different tables to create all those relationships. Joins really don't exist in DynamoDB, and again, I mean that's by design, right? Because they don't want you to go to all these different tables. You have it all kind of just in one. And then cost structure, right? In Oracle DB2, those other types of big databases, right? You pay for licensing, right? You pay a license per CPU, and it's charged a certain way. DynamoDB is really not priced out that way. It's priced more of think of it more like a utility. What you're using, it's basically based off of usage, right? So if you're not using it that much and you're not writing and reading to it, you're really not getting charged for it. But once you start using it, more reading and writing, then you start getting accruing charges and so forth for it. Yeah, so it goes more, it's truly more of a serverless approach, right? Kind of like what, and so forth. I'm sorry here. Yeah, so just some quick basics, right? So we can become familiar with it. You still have the concept of tables, right? Tables still exist. You have items, and that's what they're called in DynamoDB. Item is like a row, right? Think of an item as a row entry in your relational database. You have the attributes that are associated with that item, right? Again, attributes are very similar to what you would have as columns in a database, right? And now this is where it starts to get a bit different, right? You still have the concept of, I need to know how to go grab a record. And you have this concept of partition keys and sort keys. So every item will need a partition key, right? Or every table needs a partition key, which is the primary ID to go get it, right? So if you have a customer, right? You have customer ID 1234. Well, that's an ID associated to that customer. That's the primary key for that customer. Now, this other piece right here, the sort key, this piece is optional. Every item doesn't, or every table doesn't need a sort key associated with it, but you'll start to see here in a bit how sort keys do help out And sort keys are very helpful in organizing and filtering data within that same partition, right? And it enables, it's what gives you the ability to, like I want to go grab all the orders for this specific user. It's 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 where the sort key kind of comes into play and starts being useful. Again, just real quick, partition keys are mandatory. Um, and you want to be really, really smart on how you develop these partition keys. And that's another thing that I think is interesting. Forgot to say this, but when it comes to DynamoDB versus your traditional relational approach, right? And your relational approach, you can afford to be lazy a little bit in the sense that, like, hey, I start off with this modeling thing. I have a customer and they have orders and all these tables. And then like later on, you think of another relationship and you can kind of bring that other table into the mix and then create the foreign key constraint and tie it in and later join that way. DynamoDB, though, on the other hand, one of the things that I do tend to like about it is you really have to think about it up front. There is this what I call the upfront tax, where you have to think about what your access pattern is going to look like. And most of the times it's very obvious, right? Once you start talking about what the application is going to be doing, you start to see the patterns that are emerge. And okay, I'm going to, you know, if I have an e-commerce site, well, it's based on a customer. A customer can do what? A customer can have orders. That order can have, products. And you kind of, you start to model it, but you know how you're going to be querying that data. And again, the better that you think that out, you're going to have a better experience when you're working in DynamoDB. And it's not to say like, hey, I can't change it later and I can't migrate to a different pattern. You can totally do that, but you definitely have to think about how some of that upfront. And here's a scary thing that if you guys ever have a chance, definitely go online. Check out some of the AWS reInvent talks. There's a guy out there, Rick Houlihan. He's done an amazing amount of talks on this. Alex Debris, the guy who created the DynamoDB book, talks about this. But there's a scary thing called the single table design, right? Again, I come from the traditional relational database, right? I want to break things up into as many tables as possible. And the single table design kind of goes against all that, right? It's saying like, hey, for an application, let's just throw everything into one table. And it's like, it just flips that paradigm on its head, right? Because now I'm having to store everything. And so what is this single table design, right? Well, it's all the data in one table. You do a partition key for grouping, right? How you're going to group that data. And then you have a sort key to kind of make the connections and make the relationships. And then you can add some indexes for advanced querying. Just want to make sure. Some of the benefits of having the single table design is optimized query performance. The data is all co-located in the same place. Querying for all the related entities is efficient because it's all on one table versus spread out and having to do the X amount of joins to get you what you need. Reduce costs, it eliminates the cross-table joins. You don't have to go out and do all this, and you have fewer read and write operations because it's all just, based off of one table. Simplified schema management. You don't have to do as many updates and migrations and all this stuff to the tables because it's all on just one. And again, because it lends itself to what it was for, the scalability is going to be there. So again, when would you want to use the single table design? Well, again, when you have a well-defined access patterns, high throughput applications, and strong related entities. It does present a learning curve, right? You have to get used to it. If you're interested in the single table design, is just go out and do a couple of data modeling exercises. And the first couple of times that you do it, I'm not saying everyone's going to be like me, but it takes a while for you to kind of like wrap your head around it. But once you see it in action a couple of times, it it starts to become just, like the second nature, right? I have a buddy of mine who does serverless applications at his day job, and he uses DynamoDB every day. And he's like, I start every single project with single table design. He's like, I try to define all my access patterns up front, and I do it off of that. And he's like, I can just do that, you know, with like it's easy now, right? Because he's done it so much. The first couple of times, you're left like, well, how do I tie this into that? And is it going to make sense for me to, you know, and the inclination is going to be there. You're going to want to break it up into another table, right? You're going to say, I should have another table to put this in, right? So this is what a single table design would look like, right? You have a partition key, you have a user, a hash, and then some kind of ID, and then it ties into the sort key, right? You have a user, profile, and then all the attributes associated with that, right? You have a user, and then their order, and that sort key, you can start to see how it's like, okay, I know that it's going to have all this order information. Well, then all that order information might have products and so forth, right? And then you have like a product, and then its details, and it starts to like, lay it out, and you can start to see how that data is going to be organized in one table. Right off the back, right? It doesn't look right? Because you're so used to seeing, I'm going to have a user table, I'm going to have a profile, order table, I'm going to have a products table. Well, now it's all just kind of mushed into one. Real quick, this is how a query would look like in the single table design. You have an e-commerce table, you have partition key, sort key, and how you start to build, the user with the user ID and the profile and so forth. So I'm coming up on time. I'm just going to go through this real quick. I started to work on, when I was originally doing the talk, I thought it was going to be an hour. And so I started working on this crazy demo, and I was going to do a Vue.js front end and so forth. I'm going to condense it down, but I started to work on a taco ordering API, right? I want to order tacos, and what does that start to look like, right? And I wanted to apply the single table design. And I remember I was doing it, and I was like, well, in a normal relational database, right, if I'm going to have the menu items, that's going to be a separate table. So for the dimensional lookups of my menu items, how does a menu item go into my taco ordering table, right? And I start to think about it. Well, I can use that partition key, right? The partition key with the sort key to create the entities, right? I have a menu item hash 001, but the entity could be taco 001. And so that's my menu item, the taco, and then the associated attributes. I have a menu item, a topping, and then the attributes that go with it. I also have a menu item and the side items. And so I start to model all that, and I come out with this, grabbing a menu. Now, this is going to take a minute because this is a Lambda, so it's not as warm as it should be. But after that, it should be pretty fast because I have a warmed up Lambda. So like now when I do hit it, it's pretty fast, right? So I grab a list of all my menu items, and I start to see like, okay, I have my ID, my name, price, food item type. And in the code, these are all tied to like the food item type is tied to like an enum and so forth. And I have some of the code, right? Like the menu handler, how I grab that, right? I'm using the menu partition to go grab me all the. So this is what the AWS SDK looks like for DynamoDB. But you can grab all the attribute values that you're going to want. You start to build the query. I do like the API for this. It has that builder pattern, right, where you just build on top of it and you chain it all together, and you have your query. I grab all my items, I convert those items into, into my menu item object, and I start to build off of that, right? I also have, I created all the CRUD pieces, right? I have one for creating an order. I want to create an order. This is what the body would look like. Now, mine was a bit different. I used my email address. I used an email address as the customer ID because I know that email address for a customer in the app is really never going to change, right? Like on McDonald's, I can't, when I sign into McDonald's, it's signed in by what? By my email address and my user. If I try to sign in with a different email, I have to create a whole new profile. I can't just say like, hey, I want to change the email now on my profile. It's not going to let me do that because it's tied into that email. So for my use case, I was like, well, yeah, I should do the same. So instead of creating like a UUID for the customer ID, well, I just want it to be my email address. So in the table, I should have probably pulled that up. It would look like customer hash a.rubalcaba at 806 technologies. Yeah, it would, and that would be the profile, right? So it would be customer hash, the email address, and then the sort key is profile, and that has all my profile stuff, right? And then I want to create an order. Well, it's customer ID hash, my email address, and then the sort key is the relationship. So it's order hash, and then whatever the order ID is, and then I get that, right? So I'm gonna create this order. All right, I got 2 minutes. I created the order successfully, and now I can go grab all the orders that I want for this specific client, or customer, which is myself. And here I grab all the orders that I've placed. And so here the order ID again goes back into, that's the order hash, order ID with my customer, and I can go just, hey, I have a customer, I want to grab all the orders, and it's very fast and efficient, and I don't have to do all the joins. One of the things that I did do for my use case is I was like, okay, well, I know the taco information. Like once you have an order and you've placed it, you really can't you really don't go up and update it again, right? Like most of the times, right? It's like when you go to the restaurant and you update the order and you're like, oh, I want to add to the order. Well, you've already paid, it's already closed out. You have to do a separate order. So I'm not updating I'm not going to update any of that information. So I just denormalize that and I put that along with the order. I don't break out every single taco into its own sort key and all that. I kind of just put it all in together because I'm not going to really be doing any type of updates. What I am going to be updating in my use cases, I really just want to update the status, right? If if I've if I have an order and it's in receive status, I want to update it to completed. Well, it's really the status that I'm updating. I'm not really updating any of the actual items in there. So I do have like a, see if I have time real quick. I have like, this is the order ID. I want to update this. I have this information. I know the order ID and I want to put it to, I think I'm missing something on there and I'm running out of time. But I have a handler that's just for updating the specific message. The specific order, and then if I was to go get it, it would do it. And I can also just query by a single order to grab all the information that I need, and again, the order items. So I have all the code for that. I'm gonna update it into, I have a Git repo. I'll try to post it on my Twitter and LinkedIn. I don't have a link to it, but if you look me up, I think I'm under Andrew Rubalcaba on GitHub. I have the code on there, and I have some Vue.js code on there as well. I know I ran out of time. I wish I could have gotten into some of the more to the actual APIs, but the code is there for you to be able to do a lot of the CRUD capabilities. More about me, again, I'm Han_Cholo on X. I'm not on Blue Sky yet. I think I created one a while back, but I've never really went in and interacted with it. Seems everybody at this conference is moving over there. And then my name is Andrew Rubalcaba. I'm on LinkedIn. please shoot me a message. Let's connect. If there's any feedback, if there's anything that you might want to see more of, or you feel that I left out, or there's a gap in your understanding about DynamoDB, I would appreciate if you send me a message, because I would love to make this presentation better. Yeah, sorry.
You had a almost metric of a real production data to show the difference.
Oh yeah, I would love to. You know what? That's a great. I will add that to. I'll add that to the presentation, because Amazon has a ton of metrics on some of that. Yeah. Yeah.
First, have you had any problem with Dynamo consistency? First question.
The which one?
Dynamo consistency, right?
Yeah. So you do have. You can. Yeah.
Let me ask the second question. The second question is, have you tried Google Cloud Spanner?
I haven't tried the Google Cloud Spanner. So Dynamo does have some consistency things that I think I should have touched based on. So you have what you call eventual consistency, right? It's a bit different. So it's like a couple seconds or milliseconds sometimes from when you write, or if you update something, to when you can read it. You can have a strong consistency, like a strong consistency read, and you can tweak that on the API. I think it's going to cost you a little bit more when you're having to do the strong read, but for the majority of use cases, the eventual consistency works. The other thing that I wanted to touch base on, and I didn't have a slide on here, is transactions, right? If you are coming from the relational world, we love transactions. It makes us feel safe, and they're great. And you have transactions in DynamoDB, they just behave a bit different, but you do have to give some thought to it. But majority of the time, you can get away without having to wrap everything in a transaction. But no, I haven't tried the Google product. Sorry, it was Google what?
Cloud Spanner.
Okay, no.
So last year, holidays, Amazon DynamoDB processed by 120 million transactions per second. Cloud Spanner did 2 billion. It's fully relational, transactions, everything.
Now, if you need 3 billion to handle 3 billion calls, my hat's off to you. You guys are going to close down on your seed rounding.
I'm just saying that because, I mean, I'll go to Google. So,
No, that's great. That's great. Nah, yeah. Hey, guess what? The best innovation comes from competition, right? It was somebody at Google that was mad. And yeah. So regardless, though, if you have that type of scale, hit me up. I'm curious. If you have billions of writes, go for it. That was it.